In this video, we're going to prove how two triangles can be similar. There are three possible ways to choose from. The first way is angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. The second way is through side-side-side similarity, which means if all the corresponding sides of two triangles are in proportion, then the triangles are similar. And lastly, by side-angle side similarity. If two corresponding sides are proportional and the included angles, it has to be the included angle, if those are congruent, then the triangles are similar. So what we're going to do is we're going to look at a few examples and determine if the two triangles are similar. All right, here are the first set of examples. In number 1, we are given two triangles that are created by two lines intersecting, two segments, DF and CG. Now, look closely. There are arrows on these sides. That means that those sides are parallel. If two lines or two segments are parallel, then we can say that alternate interior angles are congruent. So there's one set of angles that are congruent. And let's look closely here. We have vertical angles. Those are congruent. So now we can say these two triangles are similar by angle-angle similarity. So we're going to determine if the triangles are similar, and I'm also going to name the triangles that are similar. So on the left, we have triangle DEC is similar to triangle FEG. The order of the letters are important. We do want to make sure that the letters are placed so that we can see how angle D corresponds to angle F. So number 1, the triangles are similar by angle-angle similarity. In number 2, it's a little challenging to see, which triangles we're referring to. So I'm going to separate these triangles apart. We have triangle LQP, and then the larger triangle is triangle LMN. Now, from the original diagram, the sides are parallel. These segments are parallel. So now we can say we have corresponding angles on both ends here. And we can go ahead and transfer that information onto our separate triangles. So we can see that the triangles are similar by angle-angle similarity. For number 3, at first glance, it might not look like they're similar. You have to find the missing angles. Now they have a 90 in common. This triangle has a 90-degree angle, and so does this one. Now, if you look closely, we've got the 39 here and the 51. They don't match up. But this is because we're going to have to find that third angle in this triangle. So remember, 3 angles in a triangle add up to equal 180 degrees. And these angles in a right triangle are complementary. So this will end up being 51 degrees. So if you notice, they do have two pairs of angles that are congruent. So we can say the triangles are similar. And lastly, number 4, we have been given two angle measures in each triangle. So let's go ahead and find the third angle in the triangle on the left here. And we get 58 degrees. And if we find the third angle on the other triangle, we find 49. And it looks like they only have one pair of angles that are congruent and nothing else. So we cannot say that these triangles are similar. We will say that they are not similar. So again, compare this to number 3. When we found those angles, we found two pairs of angles that were congruent. So we can say that these triangles are similar in number 3. But for number 4, you can see one triangle contains 68, 54, and 58. And the other triangle contains 49, 63, and 68. And having just one pair of angles is not going to cut it. All right, so let's look at the second way we can prove that triangles are similar. We're going to look at side-side-side similarity. We want to determine if the triangles are similar by side-side-side similarity. So now what we have to do is compare the side lengths. We want to see if the sides are in proportion. Now, the first thing we're going to do is try to match up the corresponding sides. I think you'll find it helpful to use a highlighter. So I'm going to use 3 different highlighters for this. I'm going to highlight the shortest side on this triangle to the left, and then highlight the shortest side on the triangle to the right. Next, I'm going to highlight the longest side on the triangle on the left, and then highlight the longest side on the triangle to the right, and then we're left with the side measure that's in the middle. So now what we're going to do is we're going to compare the side lengths. So I'm going to list the triangle lengths for the first triangle here as 9, 13.5, and 27, and place them all over their corresponding sides on the other triangle. So 9 corresponds to 14, 13.5 corresponds to 21, and 27 corresponds to 42. And what we're going to do is we're going to simplify each one of these fractions and see if they equal the same value. Now 9 over 14 cannot be simplified further, so we'll leave it 9 over 14. 13.5 over 21 does reduce down to 9 over 14, and so does 27 over 42. So what we're seeing is that all 3 sides have the same ratio. They have the same scale factor when they reduce down. So we say that the triangles are similar through side-side-side similarity. So this is what we're looking for. So your work is just finding out which sides correspond, placing them into fractions, and then reducing those fractions. So let's do that with number 8. Now what might be helpful with number 8 is to redraw the 2 triangles into 2 separate triangles so I can really identify which sides correspond. So I'm going to redraw W, X, V, place those measurements on that triangle. And then I see on the larger triangle, I've been given the 56, but I haven't been given the measure of WY. I've been given measurements of 15 and 16. I'm sorry, 15 and 6. So what we're going to do is we're going to add 15 and 6 and get 21. And then on the other side, we have 20 plus 8, and that gives us 28. So if you see, it is helpful to get the triangles drawn separately so we can start to compare sides. Now, the shortest side on this triangle below is 21, and the shortest side up above looks like it's 15. The longest side on the top triangle is 40, and the longest side below is 56, and that leaves us with the one in the middle as 28 and 20. So I'm going to get a little more space going over here. Hold on a moment. All right, so let's compare these side measures. So I'm going to take triangle 1, list those side measures in order, 15, 20, and 40, and go to triangle 2 and do the same thing. Let's list those side measures in order. 15 corresponds to the 21, 20 corresponds to the 28, and 40 corresponds to the 56. And take a moment to reduce all 3 fractions and see if they all simplify down to the same ratio. The first fraction reduces down to 5 over 7. The second fraction also reduces down to 5 over 7. Looks like we're on the right track. And the last one reduces down to 5 over 7 as well. So we can say, yes, these triangles are similar through side-side-side similarity. Now I have 4 more examples here. I'm not going to do all of them. I'm going to choose to work with number 9. All right, so let's take a look and find our corresponding sides. We've got the 3 and the 5, shortest sides. The longest sides are 10 and 16, and then the ones in the middle, we have 12 and 7. Let's go ahead and put 3, 7, and 10 in order, and their corresponding sides. We've got 5, 12, and 16. Now, 3 over 5 does not reduce, 7 over 12 doesn't reduce either, and 10 over 16 does reduce down to 5 over 8, but I mean, you can already tell right off the bat that these 2 fractions that don't reduce, these are not proportional. Take a closer look. They're not proportional. If you cross multiply 3 times 12 is 36, and 7 times 5 is 35. Those are not equal values. So the sides are not in proportion. So here's a situation where the triangles are not similar. All right, so this is our goal for this lesson, is to take all three sides and compare the ratio of the sides. All right, the next one is going to be side angle side. This one, keep in mind that we're working with the angle in between the two sides that have been given. So with number 13, I'm still going to be looking at the two separate triangles. Here's triangle 1, triangle 2, so you know what I'm working with here. On triangle 1, 6 is the shortest side here, and on triangle 2, 24 is the shortest side. So I'm still comparing sides if I'm trying to show that the sides are in proportion. Longest side on triangle 1 is 12, and longest side is 48. So the first thing I'm going to do is find out if the sides are in proportion, and then I'll try to find the included angle and see if they're congruent. So here's step 1. We're going to take triangle 1, those measurements of 6 and 12, and put them into proportion. 6 corresponds to the 24, and 12 corresponds to the 48. If we simplify these fractions, we will get 1/4 and 1/4. And what this is showing us is that these two sides are in proportion. Now, in order to use side angle side, we also need the included angle. So the included angle between these two sides is this angle around point E on this side. These are vertical angles. And since they are vertical angles, we can say they are congruent. So angle FEG is congruent to angle RES. All right, so we have it. We have the angle congruency. We have the two sides that are in proportion. So we can prove by SAS similarity that yes, these two triangles are similar. Let's look at number 16. Here it is. Let's compare those sides. Shortest side here is 45. Shortest side there is 31.5. Longest side is 50 on this triangle. Longest side is 35. So we're going to place that into a proportion. So we've got 45 over 50 equals 31.5 over 35. So let's go ahead and compare those side lengths. And it looks like they both reduced down to 9 over 10. So we've got the sides. Those sides are in proportion, so we're on the right track. We just want to find out if the included angles are congruent. So let's take a look at those congruent angles. They've already been marked up congruent for you in the diagram. So we've got angle G is congruent, given as congruent to angle H, and that's what we were looking for. So yes, these triangles are similar. I'm going to backtrack and do number 15 because it is a little bit of a challenge, or we're working with some parallel sides here. And here we go. So we've got that this side is parallel to this side, and we've got this transversal coming through. We've got corresponding angles right over there. So we've got the parallel lines or parallel sides with the transversal, and we have those corresponding angles. All right, let's compare the sides. The triangle to the left, we've got 36 as the shorter side, and on the triangle on the right, it looks like we have the 22. Longer side on the left is 54, and the longer side on the right is 33. So let's go ahead and compare the sides. We've got 36 over 54 equals 22 over 33. Let's go ahead and reduce these fractions. And it looks like they both reduce down to 2/3. And so the sides are in proportion. We just want to find out about our angle, the included angle, which we already marked up as those corresponding angles. We have that angle CMP is congruent to angle RPQ. So now that we have the included angle, we can in fact say that these two triangles are similar. And we're good to go. All right, so if you have any more questions, just leave me a comment. All right, have a great day.